Hey guys, Bitmaster here, coming back at you with another video. This video was requested by one of my followers, Ackerwatt, I believe is his name on YouTube. So shout out to him for requesting this. In this tutorial, we are going to be discussing multi-threading with synchronizational events. And the best way that I could think to do this for you was to create a visual representation of what a thread would be doing, just like I did in my other videos. Now, I'm going to give this a quick run to show you the finalized result, and I'm going to show you what happens and how this works. We'll dive into the code in just a moment, but for now, I just want you to understand what we're doing exactly here. So, when I start these threads, you'll see that the normal color will be green if they're running. If they're waiting for synchronization, they'll be yellow. And if they're lime green, that means they're in the process of synchronizing, okay? So try to get those three colors in your head, okay? I probably should put a little thing up here with color codes, but I didn't do it. But anyway, I'm going to click Start. And as you can see, the threads run until they get to about 25%. Remember, yellow means that the threads are still active in the background. They're just waiting for synchronization. So if I click the sync button, you're going to notice a very subtle change in the color. So when I click the synchronize button, we're calling the synchronize event for each thread. And when we do that, the threads synchronize and continue going down the line. They count from 0 to 100. Okay, that's the progress bar's entire length, which is from 0 to 100% progress bar. Now, when I click sync, you're going to briefly notice for just a split like millisecond or two. I mean, it's just barely enough for the human eye to catch. So really pay attention. But when I click sync, you're going to see these turn lime green, which signifies their synchronization process. And then they're going to keep running until they need to do something else. So I'm going to click sync. And as you can see, they were a lime green for just a moment until they all synchronized and processed up to 50%. Now I hit sync again, lime green and then green, lime green and then green. You see that? So I'm going to stop all the threads, and we're going to go back to start again. And that's that. So watch this. I'll click sync, and they're lime green and green, lime green and green. And see, it's an instant synchronization of all three threads. You see that? So I'm going to stop all threads. Start, stop. See how I instantly stopped them all? Start, stop. And this is how you stop all the threads immediately. This is how you start all the threads immediately. And that's how you synchronize them. Synchronize. Synchronize. So with this visual representation, I hope that I can try to guide you through the programming of this, and you'll understand just a little bit better, maybe, because I know threading can be like really hectic if you don't, kind of grasp it right away. I know it was hell for me when I was learning too, especially whenever you want to thread with different things. Like the threading is just absolutely insane. In any OS, you can thread pretty much anything, pretty much literally anything, and you just got to know what you're doing. So let's dive into some of the code. Let's go up here. I did not make a separate unit like you requested, and I'm sorry for that. But I just don't feel that it's really necessary. Trying to teach people, you want to keep the code in one unit so it's easier to understand. However, I will explain to you, like, you could easily copy this to another unit and all of its events to another unit, and then just include that unit here, like my threading unit, if that's what it was called, .pass, only you don't put .pass there. You just include your unit wherever you've got your T-worker thread stuff on there, and it'll do it, and you can call it from any unit. It's extremely simple stuff, right? So I'm not going to be doing that. I'm just going to leave it as it is, but we're going to go through this code. So I've commented everything professionally. I tried to get AI to just kind of go through it and comment it for me because I didn't, I didn't want to have to sit here too long and comment every single line. So it did a really good job. I looked through it several times and made sure that everything was exactly as it needed to be. So let's go ahead and start at the top. So obviously this is a Delphi unit, blah, blah, blah. Here's all my uses. It's auto generated. You don't have to worry about that. But what we do have to deal with here is our tworker thread class, which is a class of tthread. In Microsoft Windows, this is going to act as a thread, which we can have multiple instances of the same thread with the same logic inside of it. So the tworker thread is what we're going to call it, twork thread. The purpose is that the worker thread that manages the progress updates and synchronization. It has a few features: progress bar visualization, event-based synchronization, which you asked for, and color-coded state indication, which, like I showed you before when we ran it, it color codes the progress bars with different colors. So when you click it, it's green. If you sync it, it's lime green, and if it's green, it means it's good. Stopping all threads. I probably could have made that red, but oh well, not a big deal. We might even do that on this. Dead serious. In fact, I probably will add it in while we're doing this or whatever. So the first thing you want to do when you're going to thread an application, when you're going to do multi-threading, you have to create some sort of thread class. So you start by calling it whatever you would like, and then it is going to be equal to a class type of tthread in Microsoft Windows. This is literally the beginning. It is so simple. You can call this anything you want. It doesn't have to be that. It can be anything you want. It doesn't matter, okay? So I'm just calling it twork thread because it makes sense. We're going to make these things work in progress, so I just called it twork thread, okay? So we're going to have some private declarations. We're going to have one protected declaration, which is a procedure for execute, and it's an override. This is absolutely necessary for threading in Delphi at the most basic root of everything, okay? So then we're also going to have some public declarations, a constructor, a deconstructor, a procedure for the signal thread, and also a sync event, which is a T event type of the whatever we're going to read from F event, which is a T event as well, okay? So we're going to take this very slowly, okay? In the private declarations of our worker thread class, I have a progress bar, an event, and a position that it's currently at. Now, this is the visual progress bar indicator. Obviously, it's the type of progress bar that I used, which is a TJVXP progress bar. So if you'll notice, each of these progress bars are a TJVXP progress bar. You see that, how I hover over it, and that's the name of it? That's the type of it, and it's over here in the object inspector, JVXPP progress bar 1, whatever, yeah? So that's why that's there. So this thread can take control of any of these progress bars that are of this type, okay? The event is a T event. So F event becomes a T event, okay? So the sync event is the T event of whatever thread is currently being controlled by this event. Or can read this event, okay? So the position, however, is an integer, and that's just the position of the progress bar, the current position of the progress bar's position, okay? We also have a procedure called update progress. That's where we're going to synchronize with the main UI and actually post the new value for the progress bar, so we don't freeze the main thread, because when you're dealing with this stuff, you have to tell the thread that it has to constantly update a graphical component, and in order to do that, you have to perform a synchronization event. Now, don't get confused. That's not what my sync thing does down here per se, okay? This is in reverse order. This button actually synchronizes the threads, not the other way around. So what I'm saying is the T thread has to perform a synchronization event here, and I'll actually just go to the code. So like right here, for example, and right here, for example, you see all this? These are synchronization events or procedures, which it's the way that a thread can update the main VCL, which is this whole thing, this whole GUI, you have to use synchronize if you're going to touch things. Like, you see how we're changing the colors here of the progress bars? In order to do that, the worker thread that we created up here, the main work thread has to touch the graphical interface. If you've heard me joking about this in other videos, I'll say no touchy, no touchy. You know, kind of like the Emperor's New Groove shit. So like, if a thread has to touch something like this or this or this or this or this, or even the form itself, you're gonna have to call synchronize. You have to call this. And inside of a procedure in there, you have to tell it what to do with the GUI. If you don't do this, then your application is going to freeze and it's going to not respond. So when you run this, if I were to click this button without the synchronized code in there, if I clicked this, it would literally freeze. In fact, I'll even give it a shot. Let's see if I can comment this out real fast, okay? So let's just do that. Just like that, and see if I can get this to go down here. You know what? I'll take this out, and then I'll just click run, see what happens. So if I try to start this, it actually does pretty good by itself. But the problem with that is that there's always the chance that in between them, like as they're running, a progress bar is pretty simple. It's only an integer value. It doesn't really affect anything, so I couldn't get it to freeze. But I can assure you that if you have more sophisticated code doing a lot of different sophisticated things, and you don't have this, you're going to be shooting yourself in the foot, because it will freeze, and eventually, with enough data flow, it would freeze the application, and like it would just like turn white, and it would say not responding like up here because you didn't synchronize. But in any case, this is just a basic example, so I can't get it to break. I guess Delphi's just the god of all languages, and wow, amazing. You gotta love Delphi, right? So yeah, let's go back up and continue talking. So we have this class thread. We've talked about it's going to assign itself to its own progress bar. It has an event that we can trigger it to synchronize with, not synchronize in the way that I just taught you, but in a different way, and we'll get to that. We have the position of the progress bar, and we have an update progress procedure, which we'll use to synchronize each progress bar. So when we go in here, this is to update the progress, so it will turn the position of the progress bar that it has control over to the new F position that we sent, or that is currently being looped through. So what we will do is, let's take a peek here. We have protected procedure for execute, which is whenever we start the thread, we will have an execute event, this one right here. So while our thread is not terminated, we do all the cool stuff that we're going to do inside here. It could be anything. It could be anything. But in this case, it's just making sure that we go through all of these different checkpoints and wait for an event and stuff like that. Now we're going to get to that, so don't freak out. So let's continue through this. So we have our execute event. We have a constructor, which is to create, a deconstructor to destroy. That's an override. So we can properly destroy each thread when they die, or if we stop them or whatever, right? You can think of a constructor and a deconstructor as kind of like a constructor is when you create something, you can have all the logic that's necessary to create something in here, like down below in the actual event here. And then whenever it gets destroyed, you can have that logic reverse itself. So you properly keep things clean. You see what I'm trying to get at? You don't have to do it this way, but this is literally the best way to do it. I do this all the time in my code. Constructors and deconstructors are amazing. So then we have a procedure for signal thread, which is going to trigger the thread continuation. This is the synchronize button thing. So whenever I click the sync thing, it's going to signal thread each one of those. It's going to loop all three threads, and it's going to sync them up and tell them to continue looping. So now that we've gone through the top portion of the code, which is all of this, the worker thread. I hope that you completely get it. This is very, very basic stuff. Just create a class for a T-thread. Make sure you've got all your stuff set up for your privates. Make sure that you've got your procedures, you've got your protected procedure for execute, which is an override. You've got your constructor, a deconstructor, a procedure for synchronization or signaling threads to continue moving or whatever you've got here. And then you've got your sync event, which is a T event of F event. Now, if that confuses you, don't freak out. We're going to go through it step by step. So, the first thing to happen, obviously, is the form gets created. So what we're going to do is we're going to first initialize the thread array. So at the very top of the code, I'm going to show you this real quick. See this private declaration right here for tform1's class of tform1? This is a private declaration, which means only this form can see it in its own memory space. So we have an fthreads, which is just our full list of threads. That's what you could consider that if you want to. Feels a bit weird to me, but that's fine. Full list of threads is an array of 0 to 2, which means it's an array of 0 to, well, it's technically 3, okay? It's 0, 1, and 2 of type work thread. In other words, we have an array, which is an array of 3 worker threads, okay? It's 3 of these bad boys. You see what I mean? We got 3 of them. 1, 2, 3. So we got 3 of those in here in the fthreads. So now we have a way to loop through the threads and control them. So what we're going to do is whenever the worker thread gets created, and I guess I should probably take you through the proper flow. So let's start with the start button, okay? When we click the start button, we have an integer for local looping. We're going to set up all of our progress bars to be 0, okay? Then we're going to loop 0 to 2, which is 3. So we're looping through and starting all of our threads. So we're going to say, here, let me go back one more. On the form create, I forgot to go through this. You got to remember to initialize your thread array. So we're going to make the thread array by creating an integer and looping to 3. And we're going to say that these threads are equal to nothing. Now, there are actually 3 blanks inside of the full threads list, which is an array of 0 to 3. Well, 3, right? So we just created 3 blanks, basically, on form create, okay? You get it? That's all we're doing. And then, when you click the button for start, you're going to make sure all the progress bars are 0. You're going to loop the 3, and you're going to actually create these threads and start them. It's really that simple. So get this. We're doing a case statement here. Case integer of 0, 1, 2. We're just quickly looping. I could have done it better than that. But in any case, we're saying that if the case is 0, then fthreads I is equal to create a worker thread and attach it to this progress bar. And then 1 and 2, create another thread and assign it to this progress bar. Create another thread and assign it to this progress bar. Then we can start all the threads at the exact same time by calling fthreads I.start. You see what I'm getting at there? Pretty cool, right? So it literally starts all the threads at the exact same time. You see? So then down below, we're just updating graphical stuff. We're just enabling and disabling buttons. That's all we're doing. Okay, this is how simple it is to create those threads. Now, we have to understand what we've done. So in order to do that, when we created those threads in memory, here's what's happening. It's going to the constructor procedure, which is kind of like it's just like a public constructor for this thread. So let's click create. So this is what's going to happen. So remember, we already looped and created all 3 threads. As we were doing that, this code was firing, boom, 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 3 times, right? So we're going to inherit create, which is true, which means it's going to create a suspended thread, okay? And then we're going to say that the progress bar for this thread is equal to a progress bar that we attached to this constructor. Now you remember that down below in the button click event procedure, we did create and we attached a progress bar right here, and right here, right? So up above in the constructor, we passed that progress bar here. So the F progress bar, which is up here in our worker thread class, we have an F progress bar, an F event, and an F position. Remember that? Remember? So the F progress bar becomes a progress bar that we attach to it. The F event becomes a new event, nil, true, false, nothing. This is just creating a synchronizational event that we can like trigger. Okay, that's all it's doing. If you want to go through the Microsoft Windows API, you're more than welcome to, but this is how it's done. Just nil, true, false, and then nothing in the last parameter. We're just creating a T event. That's all there is to it. So the F event is equal to this new event that we just create, okay, in memory. Then we're going to set the F position of this thread to 0 because the progress bar starts at 0. Okay, so now that it's been created, so now we understand how to create it, but what about when we click the button? So let's go back to the button code. When we click the button, we're looping through all 3 threads and creating them, but that doesn't mean much other than we just created those threads and set them up to start running. But when we call .start on all the threads in our array list, or in our array, then what happens? Let's hold down Control and Start and go to the flow. This is system.classes. It's a Windows API telling that T thread to start. In other words, let's close this out. What we'll do is when these threads start, they're automatically going to call on execute. So let's go back up to the top of our code here. Let me show you what I'm talking about. So we understand how to create the threads. We understand that they exist in memory, but they're not necessarily doing anything until we call start. When we loop our threads and say, hey, get to work, start, that means they're going to start. And that means they're going to call on execute. So this one right here, so let's click on that. We have overridden. Now, if you'll notice, I really should have showed you this, but the reason that we call override here, let me show you something. I'm trying to find it. Okay, on the where the heck was I even at? I'm losing my mind here. I'll just go to the stupid button. So like right here where we start this bad boy, you see how we're inside of the system.classes API Pascal file, the Delphi headers for Microsoft Windows system.classes API. There's suspend, start, and then if you see, there's probably an on execute somewhere in here. This is not exactly what I'm looking for, but it should be around in here somewhere. Yeah, so this one right here. See this? This is execute. It's a virtual abstract. So like if we click on this, yeah. So this procedure exists in this code to be able to tell a thread that it will need to begin execution in Microsoft Windows. Now, what we're doing is we're taking the power away from this thing because it allows it to be virtual and abstract. What we're doing is we're actually creating, here, let me go back up real quick. See how we have procedure execute override? So this is execute in here. If we left it defaulted, we would have to use like whatever's in here. In fact, you can't really, it doesn't really have anything in here. You have to override this one in their code so that you can make it work with whatever you're doing in your code. That's why you put the override word there, the override directive keyword. So now we've taken control of execute, and we can have our own on execute event rather than being at the mercy of whatever the hell this thing is. And if I could find the code, I would love to look and see even what that has in it. Let's see here. Yeah, I just don't see it. I'm blind. I'm blind. I don't see it, I guess. But it's probably way down in here somewhere, and it's probably got some stupid, probably just some stupid, silly thing. Here, see, here's where that T-anonymous thread stuff comes into play. But in any case, this is a waste of our time. This is just thousands of lines of Windows API code that is already written for us, and we don't have to really worry about it. These are the Delphi headers for all the Windows API system.classes. All we're doing is stripping it away and overriding it from theirs to ours. So we can now create our own execute event. So let's go ahead and click on our execute event, and let's start talking. Okay, so now we're going to get into the meat of the app. Okay, so when each thread executes, we've overridden the ability from the other pass file, so we've taken control of the thread, so to speak. I'm trying to think of easy ways to explain this to you guys. I really hope I'm nailing it for you, just making it super easy for you to understand, because this stuff is so easy, right? So like the worker thread will execute. We're going to say now I want you guys to remember, it's going to be boom, boom, boom 3 times, because we're going to have 3 threads working in the background. So this happens 3 times rapidly, once for each thread, but each one is contained to its own thread, which is really cool, right? So we're going to say while the thread is not terminated, which means it is in the background or it's processing data. It's not dead yet. We haven't terminated it. So while the thread is active and live, we want to set the F position. If the F position is less than 100, then we need to increment the F position, which means push it forward, like 1, 2, 3, 4, 5, 6, 7, 8, right? You follow me so far? Then we're going to call synchronize update progress. Synchronize is actually a Windows API call for T-threads. So like if I click on this synchronize right here, it's going to take us back to tthread.synchronize, which is self, which is the thread, and a method, which is a tthread method. This is Windows API. So I'm going to go back. So what we're doing is we're saying we want to synchronize whatever the hell we want, which right now is update progress. So if the position of the progress bar is less than 100, or if the position right now is less than 100, we're going to continue inking it, which means incrementing it up, and we're going to synchronize every single time we do. We're going to update that progress bar, and we're going to sleep for 100 milliseconds, which is just boom, 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 boom. It's like it's almost a nanosecond, right? We're just allowing it a little sleep time so that the animation goes a little bit smoother. You see what I'm trying to say? So, so the update progress, we're going to synchronize this. Let's go ahead and click on that. So when we call synchronize, we're actually synchronizing the entire update progress tworker thread procedure. So you see how here we don't have anything like you would probably think, oh no, Bitmaster, you would have to type in synchronize here and then do it here, right? No, we don't have to do that, because we actually have our own private tworker thread update progress event procedure. If you'll notice up here in the private declarations, I put update progress. So whenever we're executing these bad boys, we actually called the synchronize Windows API on that event. So it will literally, whatever thread is running will constantly loop this through and synchronize to update the progress bar. That way it doesn't freeze the graphical interface of the user interface, right? And then it will sleep for 100. Now going down, it's also going to we're also going to handle synchronizing for checkpoint handling. So we're going to stop the bars at 25%, 50%, and 75%. So if the F position is in this range, or it's in this exact value of this range, 25, 50, and 75%, then we're going to synchronize our own procedure. This is just a really dirty, quick way of synchronizing. Okay, we're gonna synchronize, and we're gonna change the bar color to yellow and say, hey, we're waiting at 25%, or hey, we're waiting at 50%, or hey, we're waiting at 75%. It has to turn yellow if they're in that range and if they're waiting for synchronization from the user. Now here's the cool part. The F event is waiting for the sync signal from the user, and that happens when you click the sync button down below. So get this, we're going to wait for that sync event signal, and then if the user does click the button and we do that, obviously we also reset this event, so we reset for the next sync point. Okay, so then if we do, we're waiting for this. This doesn't happen. So guys, this right here, all of this does not happen until the user sends that event. Okay, so if the user, if it's waiting for us, and if we click, so if we click this button and it causes the event to have it sync, the wait for thing is ticked on to true. So it's like, oh, the user clicked the button, so we need to go ahead and reset for the next time and proceed going down the code. You see what I'm trying to get at, guys? So if we did send the button click to make that event fire for the wait for, then we reset that wait for event and we synchronize our bar color to lime to show, hey, all the threads are synchronizing, or this thread is currently synchronizing. And then we sleep for 200 milliseconds just to give a little bit of time so we can see, like, visually how long it took for them to synchronize, which is obviously 200 milliseconds, okay? And then down below that, we're going to also synchronize back to green because they're going to continue moving forward. You kind of get that? And that's it, guys. Like, literally, that is so far the entirety of the program. Now what I would like to show you now is this F event, wait for, and reset event. These are Windows API calls. So it's a wait for, a timeout, which is a cardinal, and a T-wait result is what comes of it. And in the API, they're saying the result is equal to error unless it's equal to something else in your own code, which you have to produce that yourself. So what we've done is we're just saying wait for the event to fire that the user synchronizes with the T event thing, and then reset that event for the next sync point, which is going to be 50 or 75 depending on whatever it's at, right? So let's double click on sync and go there. So if we synchronize, if we're ready to synchronize all of our threads with an event, we're going to create an integer for localized looping. We're going to loop to 3 and for all 3 threads. If assigned the thread that we're looking at, then we will signal that thread. Signal threads to continue. Now guys, if you look at this, signal thread is a event, and see how they have it coded, like, or I have it coded right here for the worker thread signal thread procedure. So the f event dot set event, we're actually triggering that event right here. You see that? You kind of get that? So if I do this, this is actually Windows API for system sync objects, and what we can see there is that this event waits to be set, or if it's not set, then it's just going to wait forever. The thread would just wait forever because the F event is not set and we didn't reset it yet. You kind of get that? That's the only weird part about this whole thing, and it's super simple to grasp. So now we move on to stop all threads, okay? So if you want to stop all the threads, you just loop them and stop them. So get this, to stop all the threads properly, we have to say if they're assigned in the first place in our array list of threads, which should be counted to 3 and should contain 3 threads at all times, then we're going to say each thread needs to terminate, each thread needs to be signaled. Because we have that signal thing, we want to make sure that we do that. We want to wait for them, and then we want to free them. So wait for them to finish, free them, and then nil them. And then we can reset the UI state back to the original starting point where the button for start is enabled true, the sync button is false because we're not running them anymore, they're terminated, right? And freed and nilled. So there's no point to have the sync button enabled. And then button 1 becomes false as well because it's terminate threads, and we just terminated them all, right? So guys, again, super simple stuff. I really hope that I've gone through this well enough for you guys to, like, grasp it. Super simple stuff, guys. The source code will be available on GitHub. Looks like I've actually got one of my bars out of place right there. It's about to drive me nuts. But like, if you run it again, you'll see if I start it up, they wait at 25% for the T event to be triggered. So we synchronized them by clicking sync, and it triggered the event so they could all continue to the next portion at 50%. And if we sync again, they synchronize all the way to 75%. And if I click it again, they run all the way to 100 and they're finished. Now I can stop all these threads, and I should have programmed it where they'll stop when they reach 100, but I didn't. But the stop all threads button stops them all. The start one loops through and creates them all, and then their on execute events fire and wait for the sync event to be triggered before they can continue. So guys, again, I really hope that I did a decent job on this. I'm just really hoping that I explained this like really well for you guys. It's super simple stuff. Just to kind of re-elaborate, I guess, this whole block of code right here is just a thread. It's just a thread with some private stuff, some protected stuff, and some public stuff. So essentially, what you'll do is each thread controls its own progress bar. Each thread has a T event attached to it, which can be triggered and reset, okay? And each thread will have a position, which is an integer of where the progress bar is represented to be at, like its value-wise, okay? We have a procedure for update progress, which basically just updates the progress bar's position. We synchronize this update progress so that the worker thread doesn't freeze up the main GUI. I tried to make it break for you guys, but remember, it wouldn't do it. I guess Delphi's just the god of all languages. Wow, we don't have to do thread synchronization, bro. Just kidding. I wish. That would be cool. So in any case, there's that. And then the worker thread has its own execute event procedure, which is an overridden one from the Windows API. So we're overriding that and making it our own. The public declarations consist of a constructor, a deconstructor, and two procedure and a property, which is the sync event, which is a T event, and it's read by F event of the current thread that's running. So for all intents and purposes, this T event, this sync event, is a T event that can trigger the threads to do things, right? And in our case, we've made it to where when we click the synchronization button, threads that are paused wait for that event to continue before they continue. You see, that's kind of like what I'm getting at. Okay, so moving down, let's look at something else. Let's see if we can do. So on the startup, again, you just set your positions to 0 on your progress bars, loop through and create all 3 threads, and start every single thread. So these just create them in memory. They're just being created in a suspended state. They're just stateless. They just sit there. That's all they do. They're just going to sit there until we tell them start. As soon as we tell them to start, each thread has an on-execute event procedure, like I told you, that's going to execute. We're saying that while the thread is not terminated, do all this, okay? Now, the thing is, it's going to check if the position is less than 100, and if it is, we're going to keep incrementing it, so we keep counting upward. And every time we count up, we have to synchronize update progress and update the progress bars to a better higher integer over and 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 over until you reach 100, right? So then we're going to sleep for 100 milliseconds just to give a little simulation thing there, right? Then we're going to ensure that every single like 25, 50, and 75, when it reaches these percentiles, we're going to synchronize and turn all the bars yellow, and then we're going to wait for our event, for our synchronization event from the user. Until the user clicks and makes that event happen, it's sat here waiting for that event. You get it? And then if that event is received, it will continue by resetting the event, synchronizing them back to lime green, some lime there to show that, hey, we're in the process of synchronizing. We're going to sleep for 200 milliseconds, and then we're going to go back to green because they're going to continue counting because this code is actually going and going and going and going again. You kind of get that? You see? Super, super, super simple stuff. So I'll run it again, and I'm sorry if I'm kind of sounding like a broken freaking record at this point, but I'm going to click start and then wait for them to get to 25% and click sync, and then they start counting again, and then if I click sync, then they lime green, and then they go green, then they're yellow, now they're lime green, green. See, lime green, dark green. It happens so fast you have to be careful, but if I stop all the threads, if I start the threads again, I can synchronize automatically the first time so that the event is already set. You see how I did that? Like here, I'll click twice, click, click. So when they get to the next point, they're automatically synchronized because I already triggered that event for the next round. You get it? So I'm going to stop all the threads, start all the threads, stop all the threads. See how I can stop them right wherever I want? Like boom, 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 boom. It just literally works. You can start them all, stop them all, sync them all, and tell them what to do. All right, so guys, it's been 40 minutes. I really hope that this has helped visualize how to kind of use an event with them. But also, I hope that you take from this and understand that when you're inside of a thread, like when you're in the execute event, if you want to synchronize something on the form, you have to call synchronize and then make a procedure to do it. This is the quick and dirty solution, okay? There are better ways of doing it, but I mean, ultimately, with an example that's as simple as this one, the dirty way works great. So whenever we want to update something or touch something's value and actually play with things on a graphical interface in Delphi with threads, you have to call synchronize. I'm sorry, I'm like a broken record here, guys, but I can't stress it enough. If you guys don't synchronize your stuff, you're going to fail miserably. I mean, you're going to see your app crash 10,000 plus times. And if you guys are like trying to do professional related stuff and you've got hundreds of thousands of lines of code rolling and you've got multiple threads running in the background of stuff, you guys really want to take this into consideration. If you don't synchronize properly, you're going to get freezes, unexpected crashes, and it's just going to drive you freaking nuts. You know what I mean? So make sure that you're synchronizing all this stuff. Now, in terms of synchronize, there's two different ways of there's two different things here. Like, you have to understand that it's all the same thing. When we call synchronize, it's expecting an argument. Here, we're actually passing our own procedure as an argument. You see that? But this is the other way of doing it. And in this case of doing it, we're passing synchronize, and then we're passing the update progress procedure, which is built inside of the thread because we put it as a procedure up here. So we're saying, hey, Mr. Current Thread guy, whoever you are that's in control of this thread, we need you to update your progress bar that you have control of. So we're telling it to synchronize this event, which, as you can clearly see, all it does is this worker thread that's currently being talked to with it updates his progress bar. That's all he does. That's all he does. He updates his progress bar position with his current position. That's it. With his current F position. That's it. It's that simple, guys. Okay, I think I've gone over this well enough. I've tried going over it maybe 2, 3 times with different wording. Hopefully you guys learn from this. I really like to show you guys how this stuff works. It's really super simple. Once you wrap your mind around T-threading, it's really super simple. But I can understand where it is a little bit scary in the beginning. So this is again a very basic example, but if you guys need another more advanced example, let me know in the comments and I'll make another video, and I'll try to if you need me to, like if you don't get it by this, let me know. I'll make some other visual representation that's far more advanced, and we'll go through that one as well. Okay, guys? All right. I'll catch you guys in the next video. Happy programming. Peace out. Oh, and Happy New Year.